So this was our first math class. This is the 10 a.m. class, and we started with fractions. We are going to multiply these fractions. We've done this a few times, and most of your kids are pretty good with it. So go ahead and write down these problems and take a minute and try them. All right, so you should have worked these out. These were just multiply your numerator, which is your top numbers, which are these two, which gives you 10 times 2, which is 20. And your denominator is 11 times 3, which is 33. So your answer is 20 over 33. Your next one, you're multiplying your numerator. 3 times 1 is 3. 8 times 2 is 16. And then the last one. The first thing that I have asked everybody to do is to put a 1 underneath that 3. That way we have a 3 in the numerator. So 3 times 1, which gives you the 3. In the denominator, we have 1 times 5, which gives us the 5. So your answer is 3/5. Right? So those should be pretty good by now. From there, we have done, let me find some division problems. So write these down, and then you can go ahead and try them. So there's one. So now we are going to do some division of fractions. So push pause and try these problems. All right, so by now you should have tried these problems. The biggest thing that we need to do is when we don't divide by fractions, we don't like to do that. What we do instead is we multiply by the reciprocal, which is the flip of the number. So we're going to flip that, and it becomes 4/9. Nothing changes with the first number, only with what is doing the dividing. Whatever does the dividing, we become multiplication and we do the reciprocal. Now we are at these type of problems. 2 times 4 is 8. 3 times 9 is 27. Okay? So when we have a division by fractions, we change it to multiplication by the reciprocal. All right, in this problem, there are 2 things we need to do. We need to remember to add the 1. Okay? It's that understood U, just like in our English class. This is just the understood 1. Again, we do not divide by a fraction, so instead we're going to multiply by the reciprocal, which is the flip, which is 1/12. The 1/4 remains the same. Now we are going to multiply the numerator, which is 1. We're going to multiply the denominator, so 4 times 12 is 48. And that's our answer. Okay. Our last problem, we need to remember that we do not divide fractions. Instead, we multiply by the reciprocal, so we're going to flip that. So it's 2 over 1. The 7/9 remain the same. Then we have 7 times 2, which is 14, over 9 times 1, which is 9. Now, that is an improper fraction. If you are in algebra or any of the higher maths, we are going to leave it like that. If you are at middle school, your book is not going to like that. If you do Saxon, even Becca, none of those books like that in middle school. In middle school, what they would have you do is 9 goes into 14 one time, and that leaves 5 left over. So 1 and 5/9. As an algebra teacher, and the fact that I want your children to begin to look forward to higher math, we actually want to leave it as an improper fraction so that we can do more operations with it. This is kind of done. This we can do more things with. So, all right, so we looked at these type of problems. These were a review. We've done these before in class. And most everybody is pretty good on those. So now, the next thing we need to do, we need to learn to reduce our fractions. For instance, let's look at 5/12 times 3/5. Okay? You can go ahead and try that problem if you'd like, or you can walk through it with me. With this type of problem, what you've done so far in previous years is 5 times 3 gives you your 15. 12 times 5 gave you 60. Sometimes you might have left your answer, but the problem is this answer can be reduced or simplified. Now, those are slightly bigger numbers, and if you do Saxon, Saxon likes to give you huge numbers. So then you'd have to figure out, well, what number goes into both of those? I do know it is 15, so what I have to do is divide both the top and the bottom by 15. That leaves me with an answer of 1/4. Now, this is what you've done previously. What we want to do is begin to look at this in a way you would do it in an algebra class. Also, if you're doing Saxon, we need to find a better way because these numbers get really big and it's hard to find something to reduce by. So what we do is 5 is a prime number. There's nothing else to 5. So I'm going to leave that one alone. 3 is a prime number. There's nothing else. It's just 1 times 3. 5, again, is 1 times 5. No other ways to look at it. Now 12 is actually 1 times 12, 2 times 6, and 3 times 4. When I look at these numbers, I don't have any 5s here, but I do have a 3. So it would be easier if I wrote 12 as 3 times 4. Now, I'm just going to write the 3 and the 5, and over here I have a 3, 4, and a 5. So I just recopied everything. We know that 3 divided by 3 is 1. We know 5 divided by 5 is 1. That leaves me with 1 times 1 is 1, and just a 4 in the denominator. I got the same exact answer, but I knew that I had these 5s that could cancel out, and you could also try just doing this. I know 5 divided by 5. I know 3 divided by 3. Okay? This is how somebody in higher math would deal with these problems, and that's what we want to begin to do. First of all, because if the numbers get too large, it's hard to find how to reduce them. Second of all, this will be much easier for us when we begin to deal with variables. So that's why we're transitioning into this type. Okay, so let's work another one. So we'll look at 3/8 times 2/3. Okay, so write that down and take a look at that. All right. What I notice is 3 is a prime number, 2 is a prime number, and 3 is a prime number. So those are not going to change. There's nothing else I can do with those. But 8 is a composite number. What that means is 1 times 8 and 2 times 4. Those are the factors of 8. The 1 doesn't help us much. There's no 8 over here. But I do see a 2. So what I'm doing is I'm replacing my 8 with this 2 times 4. And that's what I'm going to write over here. Now, these 3's, 3 divided by 3 is 1. Or 3 divided by 3 is 1, depending how you like to write it. This 2 and this 2 are going to cancel out because 2 divided by 2 is 1. So depending how you like to write it. That gives us an answer in our numerator, 1 times 1, which is 1. And our denominator leaves us with a 4. And so we have the answer of 1/4. If we had just multiplied this, 3 times 2 would have given us 6. 8 times 3 is 24. You would have to take this number and divide it top and bottom by 6. And you would still get this answer. Okay, so just depending what stage you're at, but this is where we want to head. All right, let's take a look at this problem. 1/4 divided by 5/8. Okay, so you should be able to get started on this problem. So go ahead and take a minute and work on that. All right, so everybody should have an answer. Let's see if it's the correct one. The first thing we have to remember is we do not divide by a fraction. Instead, we multiply by the reciprocal. That's the very first thing that we need to take care of. And I know this is 1 and this is still the 4. Now, I know 1 is a prime number. I know that 5 is a prime number. Now, I know right away that 4 goes into 8 2 times. So if I see that, I can just divide it out right there. If I don't see this, I know that 2 times 4 equals 8. So I can replace that 8 with a 2 and a 4. There's the 4 down there. And you can see again, those 4's cancel out. That leaves us with 1 times 2, which is 2, and a 5. So our answer to this problem is 2/5. You again could write them out. The 2 times 4 here is from the 8. Okay. I didn't need to change this to 2 times 2. For this purpose, 1 times 4 worked because my 4's canceled out. Okay, but we want to eventually get it over here where we see this before we have to write everything. So that's what we did with fractions today. So there's 3 more of each of those type that you can practice. And we will continue to work on the reducing ones because they're the most important and you get to practice the same techniques when we reduce also. Okay, the next thing we did in class today was we solved equations. We've been doing equations for a while, so this was nothing new. It was just something that we want to continue to work on. So the problem we're going to look at right now is 5n plus 3 is greater than or equal to negative 12. Now, we've done many of these problems. The only thing that is different is this inequality symbol. You're going to do the same exact steps. So I want you to push pause and go ahead and do this problem, but do it the same way, just like that was an equal, like we've done many, many times. So go ahead and try that one. So you should have an answer by now. What we're going to solve for is we're solving for n. N is your variable. We've talked about this is the family. This one already went home. It already crossed that line. It went back to its house, so we're good with that one. This is your family, but this is your aunts and uncles. This is you. This is aunts and uncles. And it's time for them to go home. So what we're going to do is we're going to send them home. To send them to the other side, to send them home, we need to do the opposite. The opposite of plus 3 is to subtract 3. But what you do to one side, you have to do to the others. When you do that, your 3's cancel out and you're left with 5n, bring down your sign, is greater than or equal to. Now be careful here. You owe me $12, and then you owe me $3 more. You still owe me money, so you're still negative. Now you owe me 12 plus 3, which gives us 15. Okay? So if you buy something, if you already owe mom $12 and you buy something for $3 more, you owe mom $15. You are negative. Okay? Now, we still want to solve for n. But this 5 is close. This is like mom and dad. They are close. But you're a teenager now, so you want to send them out of the house. So we're going to do the opposite. The opposite of 5 times n is to divide. So we are going to divide both sides by 5. Now make sure you use the fraction bar to show that division. You don't want to use the dividing sign that you've used in elementary school because it's going to get too messy as we get bigger equations. So we're going to just go to this. We know that 5 divided by 5 is 1. That leaves us with n is greater than or equal to 15 divided by 5 is 3. We didn't do anything with the negative sign. It's still there, we didn't touch it, so we're going to bring it down. So our answer is n is greater than or equal to negative 3. Now, when we have an inequality symbol, we are actually able to graph this on a number line. Our number line is called n. Now, we've talked about many times, I like to see the 0 just so I know where your middle point is. This is 3, so I'd like to see a positive 3. and a negative 3 because that lets me know you know where the positives and negatives are. Now, does n equal negative 3? In this case, it does equal negative 3. So instead of an open circle, we are going to color in that circle because it does exist at negative 3. Now, n is bigger than negative 3. If you move to the left, you would be getting smaller. So instead, you're going to move to the right. You're going to color in your arrow because it does continue, it does not stop. And we're going to color in the number line because every single one of these pieces is an answer for n. So all of these are the solution set for n. Your solution set includes integers, whole numbers, counted numbers, and real numbers. And we talked about that, I believe, the first week. Okay. All right, so here's another problem. This one looks a little bit different. And what you should be noticing is there is an a on either side. There is a variable on either side. Okay? That's different for us. We've not actually done that before. Okay? Now, you can do this two different ways. I'm going to show you both. We can move this A with the other A so that they are together. They don't want to be separate, they want to be together. We want to get all the apples on one side. For me to move this A to the other side, this is a negative 2. We do the opposite. The opposite of a negative 2 is a positive 2. So we're going to add positive 2a. There's that point where we're going to cross over to the 3a. Now, those are like terms. I couldn't have added the 2a to the 5 because that's saying 5 people and 3 apes. That doesn't go together. They're not like terms. But here, 3 apes plus 2 apes gives us 5 apes plus 5, keep the sign, greater than, and these go away, so that actually leaves us with a 0. Now, you are able to solve this. This was new, but this is the same thing as you've done before. Okay? It is on the other side. It looks a little bit different. It's a little twisted from this, but it's still the same thing. We are still solving for A. That's still our variable. And we're going to send those aunts and uncles home first. So go ahead and pause the video and work that out. Okay, so we want to move the 5 to the other side, the aunts and uncles. We do the opposite. The opposite of a plus 5 is minus 5 on both sides. When you do that, these cancel out and you're left with your 5a is greater than, 0 minus 5, which is just your negative 5. You still want to solve for a. This says 5 times a, so you want to do the opposite, which is division. So we're going to divide both sides by 5. That leaves us with a is greater than 5 divided by 5 is 1, and we didn't touch that negative sign, so it's going to remain. All right. What happens, though, if you chose to move the 3a to the other side? It is not wrong at all. We want to get all the a's on one side. So if we move this 3a to the other side, this is a positive 3. We are going to do the opposite. Since this is plus 3, we're going to subtract 3a from both sides. Again, we're crossing over this point. When we do that, those 3a's go away and you're left with 5 is greater than, all right, -2 and -3a. They are like terms, okay? 2 and 3 gives us 5a, but you owe $2 and now you owe $3. That means you owe $5 now. Now, if you look here, it's very similar. Okay, just the negatives on the different side. So we'll take a look at that. We want to solve for a. This says -5 times a, so we want to do the opposite. So we're going to divide both sides by that -5. Okay. That gives us, those cross out, a. 5 divided by 5 is 1. We didn't touch anything with the negative, so it still remains. Now, this is where something tricky happens. We are actually going to flip the sign, okay? Whenever you multiply or divide by a negative number, then you're going to flip the sign when you're dealing with inequalities. Now, notice, a is greater than -1. A is greater than -1. This, when you move that 3a to the other side, you have to deal with negatives, which means you have to flip the sign, but over here you had to do 2 steps. Here you had to do 1 step. Either way you get the same answer. I would suggest if you're not very good with negatives, you would have taken this step, okay? But either are correct. Now, we need to put our answer on a number line. So go ahead and take a minute and do that. So, does a equal -1? No, there's no equal sign. So what you're going to do is you draw an open circle around that -1. You don't color it in because it does not equal at that point, but it does have something to do with -1. Now, our a is bigger than -1. If I go to the left, I have smaller numbers. If I go to the right, I have more positive numbers, bigger numbers. So we're going to go to the right. Again, we color in our arrow and we color in our number line. Okay. Now, we talked about today in class, if this was the apes are greater than -1, can you cut an ape in half? No, but that means you can't have 0.5, -1/2 of an ape. You can't have a +1/2 of an ape. You could have 0 apes. You could have 1 ape. You could have 2 apes, 3 apes, 4 apes. So if you were looking at an animal, for instance, you would actually put dots on the numbers because these are integers. We chose to do this, which is real numbers, saying we do have halves and such. Maybe we were looking at money, okay? Alvin has in his wallet more money than this, greater than -1. And so we graphed that. If you were looking at animals, you can't cut them in half, or you shouldn't. So then you would have to put dots because those are integers. Okay? And the last thing we looked at today. We looked at this problem, x plus y equals 6, okay? Now, this is a little bit different because there are 2 variables. Whenever you have 2 variables, someone's going to have to tell you what to solve for. I'm going to tell you I want you to solve for y. The reason we're solving for y is we are going to graph. And we want to begin to look at something called slope-intercept. For our purposes, I'm just going to mention these words so that everybody can understand what we're doing, so that when they get to algebra, they will be able to do this and they will understand where it comes from. Okay, so we're going to solve for y. Same idea as we did here. Since we want to solve for y, we have to get everything over our line. We're going to send the aunts and uncles home first, so we're going to send x to the other side. This is a plus x. It's understood, but it's a plus. So we're going to do the opposite. We're going to subtract x from both sides. When you do that, you're left with y equals. Now, we want to combine like terms. 6 and x, are they like terms? 6 people, x-rays. Are they the same? No. So since they're not the same, we have to leave them separate. So what we're going to do is write minus x plus 6. You could also write 6 minus x, but slope-intercept form says that y equals mx plus b. So we want to begin to think of putting the x term first to get us prepared. All right, so now we've solved the equation, but now we have to graph this. To graph this, what we're going to do right now is we are going to make a table. Your x is your input. It's what you put in. You get to choose the x. When you choose the x, you're going to get an answer or an output. That answer comes from this equation, negative x plus 6. Okay. Now, the first point that I always put, the first x I always choose is 0. When I put in 0, I get negative 0 plus 6. Well, negative 0 is just 0. So 0 plus 6 is 6. That gives me an ordered pair of 0, 6. Don't forget, it's x comma y. So the first thing I'm going to do on my graph is put the point 0 in my x direction and 6, 1, 2, 3, 4, 5, 6 in my y direction. Okay? And that would be the first point you would put on your graph. This point here is very important. It is actually known as your intercept, your y-intercept, because it's intercepting, it's crossing the y-axis. That is actually this point here, your B. Your B is your y-intercept. This is when x is 0, you get a certain number for your y. In our problem, it is 6. And that's the first point you put on your graph. All right, from there we pick another number. So if you're feeling comfortable, push pause, pick 2 more numbers and put them on your graph. If you're not comfortable, I'm going to pick some numbers and you can follow along. All right, the next number I'm going to pick is, I'm going to put in a 2. When I put in a 2, I get negative 2 plus 6. I owe $2 and I got paid 6. That means I now have 4. So my ordered pair is 2, 4. When I come over to my graph, I'm going to go 2 spaces in the x direction, and I'm going to go 4 spaces in the y direction. Now, 2 points make a line, and that's for geometry, that's an important fact. But if you've made a mistake, you might think that's the answer. What I suggest is a 3rd point, because 3 points lets you know you made a straight line. So I'm going to pick another point. I liked how this number went down. If I had picked something bigger, I would have possibly gone up. So you want to kind of look at the points you're picking. So I'm going to pick, I'm actually going to pick -2 to get some practice with negatives. So this says a negative, my x value, -2 plus 6. Now we've talked about this previously. 2 negatives are like a magnet. They come together and make a positive. So negative times negative, they together like a magnet and they make a positive. So this is now +2. So +2 plus 6 is 8. That means this ordered pair is -2, 8. Now 8 is getting a lot bigger. So when I went to a negative number, I actually got a lot bigger number. So if you wanted a smaller graph, I might have picked 4 or even 6. Okay, for instance, if I pick 6, then I get -6 plus 6. Well, these cancel out and that leaves me with a 0. Okay, so you could pick many different points. Once you've picked your points, come over here and put them on your graph. So for -2, 8, -2 in the x direction, 8 in your y direction, which is somewhere around there. For 6, 0, there's 1, 2, 3, 4, 5, 6. 6 in the x and 0 in the y. Now, students saw earlier I'm not real good at drawing a straight line, so I'm going to somewhat line this up and do that. Okay, put an arrow on your line because it's a line and it goes on infinitely. It does not stop. Okay, and you have just graphed this equation. Y equals -x plus 6. When you look at your graph, just like in reading, we read from left to right. So if we go from left to right, what happens? Are we climbing a hill or going down a hill? That's right, we're going downhill. Okay? So if you're going downhill, are you positive or you're negative? You're negative. So that tells me my slope is negative. Your slope in this equation is the m. Okay? So we want to begin to look at those things and see how they fit together so that we can use them as we get farther along. Okay? You do have homework for next week. We do have class next week, the 12th. Okay? Make sure you watch this video and try the problems because we're going to go on from there next week. Okay? If you have any questions, leave them in the comments and I will see you next time. Bye.